Okay, good afternoon, class. So today we're looking at the leadership college paper 2. At this point, we already have recorded the whole of paper 1 as well as question 1 and 2, including a good couple of questions of question 3. But that's where we stopped last year with the grade 11s, okay? So as I explained to you guys, we're going to start with question 3 again and then just complete the series of videos dealing with this paper. Alright, so we are asked to, in question 3, refer to the figure where A is negative 2 and negative 5 and 2, B which is 1 and 4, 14, C which is 5 and negative 4 are the vertices of triangle ABC. E is the midpoint, as indicated here, is the midpoint with DE being perpendicular to AC. Then we are told that with D on AC. Alright. The question says find the length of BC. And this is 3.1.1. Find the length of BC. Okay, close. Okay, so this is 3.1.1. The length of BC, I'm going to use the distance formula, of course. It's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So you're going to square it off. So BC, B as we said is 1 and 14 and C is 5 and negative 4. So it's going to be 5 minus 1 squared plus negative 4 minus 14 squared. So the length of BC is going to be 4 squared plus 18 squared. Is just 2 root 85. Is that correct? 2 root 85. Okay. And the next question, let's calculate the coordinates of E, the midpoint. Calculate the coordinates of E. As we know, E is the midpoint of BC. Okay, so that's the midpoint. So how do you calculate midpoint? X1 plus X2 over 2. Y1 plus Y2 over 2. People, these formulas you guys must memorize for your exam, okay? We're not going to get the formula sheet. Alright? We won't be given the formulas in the exam. So you got 1 plus 5 over 2 and 14 plus negative 4 over 2. So 6 over 2 which is 3 and 10 over 2 which is 5. That's going to give you E which is 3 and 5. 3.1.3. The gradient of AC. So how do you work out gradient? Change in y with change in x. So y2 minus y1 over x2 minus x1. Okay. AC. Okay, so I'm going to say minus 4 minus 2 over 5 minus 5. So that gives you minus 6 over 10, which is negative 3 over 5. Okay. You all agree with that? Right. So all the calculations that I've done, all these answers are on the diagram. As you can see, we're running out of space there. And I want to keep the diagram in focus. Okay. Right. The next question is find the coordinates of D, the y-intercept of AC. So how do I work out the y-intercept? We did x equal to 0 for the straight line, not so. So in other words, I need to calculate the equation of AC. So we know that the gradient of AC we just calculated is negative 3 over 5x plus c. Now in order to calculate c, which is also your y-intercept, I can substitute either a or c into. Not so. So we substitute a, which is negative 5 and 2. So x and a 1. So 2 is equal to negative 3 over 5 times negative 5 plus c. So this works out to be negative 3 becomes negative 1. Not so. So therefore the equation is y is equal to negative 3 over 5x minus 1. But that's also your y-intercept. Therefore d is 0 and negative 1. Okay. 3.1.5, the question says, determine the equation of ED. So what do we know about ED? It's perpendicular, not so. Perpendicular to AC. Lines are perpendicular, what do we know? Product of the two gradients is negative 1. So the gradient of DE times the gradient of AC is negative 1. So if AC's gradient is negative 3 over 5, then DE is going to be 5 over 3. Not so. So therefore, the equation of that line is y is equal to 5 over 3x plus c. But what do you see value here? Negative 1. So this is my equation of that line. Y is equal to 3 over 5 over 3x minus 1. Okay. Any confusion there? No? So again, all that we have calculated is again on the diagram there. Next question. We are asked to show that AB is parallel to ED. But what's the gradient of ED? 5 over 3. So if we can prove that the gradient of AB is 5 over 3 as well, then I've done the job. Not so? So let's go. 3.1.6. So the gradient of AB is equal to, changing y over changing x. So it's 14 minus 2 over 1 minus 5. That gives me 12 over 6. Is that correct? 12 over 6, which is 2. So this is actually not parallel. Not so. Just go to the memo. What did I write in the memo? Okay, so this question should have read, determine if AB is parallel to ED. Then it would have been fair, no? But if they say show that AB is parallel to ED, then it has to be parallel. You must just confirm. Okay. So I think when this happened, I just gave the learner the mark as long as they attempted the question. So the mistake is from my side. Okay. So the gradient of this line is 2. But I think I would need that actually to in the follow-up question. Okay. But okay, let's see how it goes. Then in 3.1.7.1, they ask to calculate the inclination of BC. So where's BC? BC is this line. So the inclination is that angle that is made, that is formed. Not so. So to work out the inclination, we know that tan is called a theta for now. Tan of theta is equal to the gradient of BC. Did we work out the gradient of BC before? No. Yeah? So the gradient of BC is change in y over change in x. So it's 14 minus 4 over 1 minus 5. which is going to give me 18 over 4, which is 9 over 2. Not so. So arc 10 of 18 over 4 or 9 over 2. So if you shift 10, 18 over 4. Here's the inclination angle of 77 comma. Negative. There we go. As you can see, that angle is obtuse. So it's negative 77,48. And then I add 180. As we want the number to be positive, which is an obtuse angle of 102,53. Okay. Any confusion there? No? AC. Now we're asked to work out (3.1.7.2) AC. There's also inclination. Yeah, this actually belongs at the bottom. So find the inclination now of AC. There is AC. Okay, the question paper memo can be found in the description box below. Okay, this is a line AC. So the inclination is, of course, this angle that is made there. Again, it's an obtuse angle. Can you see that, people? Do we have the gradient of that line? Yes. So let's call that alpha for now. So tan of alpha equals the gradient of AC. We know the gradient of AC to be negative 3 over 5. So alpha works out to be arctan of negative 3 over 5. And negative angle of negative 30, 96. What do I do with that? Add 180. So plus 180 gives you 149,04. This angle 149,04. Okay. And then in 3.1.7.3, they ask you to work out theta. Okay. Okay, so that's within a right angle triangle. It says hence. So hence I must use the previous calculations. So this is 102, so this angle here is also 102. Not so. I'm going to move this over a bit. Okay, so that's that angle. Huh? How many for 2 more? Any ideas? Oh, this angle here, yes. That's right. You see the exterior angle is equal to the sum of 2 interior opposites. Yes, you. No, it's not. So there is a triangle there. Not so? It's right. That's a triangle, no? So firstly, this angle here is also 102,53. Why? vertically opposite. Not so. So we're going to say the exterior angle, which is 149,04, is equal to 102,53 plus theta. So theta is equal to 49,04 minus 102.53, mean angle of 46,51. And there we go. Is that correct? Okay. This diagram is just, there's a lot of information here. Okay, so I needed to see past that information given there. The last question. Right. So this question is not pertaining to this diagram here. No? Different question. Stay out of the camera, come this way. Yes, Michael.
The examination timetable.
Good time, thank you. Pleasure. Okay, so in 3.2, we got P, which is A, and B minus 3 lies on that line. And Q, which is negative 2A and B plus 1 lies on that line. Determine the value of A and B. It's two unknowns, so it will definitely go into simultaneous equations. Not so. So, if this point is lying on that line, so we'll substitute P, which is A and B minus 3, into 2x minus y plus 2 is equal to 0. Of course, you don't have to write this down. Okay? So, then remembering that's a x and a y. So, I got 2 times A minus B minus 3 plus 2 is equal to 0. I'm going to tidy this up a bit. So 2A minus B plus 3 plus 2 is equal to 0. So B is equal to 2A plus 5. I took that B over the equal sign. Okay. And this is, of course, equation 1. Then what am I going to do is I'm going to then substitute equation point Q, which is negative 2A and B plus 1, into, of course, the equation on which is lying on, which is y is equal to 3x minus 2. Okay? By doing that, we're now going to say, okay, that's an x and a y again. So b plus 1 is equal to 3 times a, which is negative 2a, minus 2. So b is equal to negative 6a minus 3. Now this is equation 2. So of course, what we do, we set equation 1 equal to equation 2. Again, we don't have to write all of the stuff that I'm underlining here. So by setting it equal to each other, the two equations, we have to just write that below that. We will have 2a plus 5 is equal to negative 6a minus 3. We get over the equal sign, so 8a is equal to minus 8. So a is equal to negative 1. How do I get b? By substituting that into one of the previous calculations formulas, either equation 1 or equation 2. So b is equal to 2 times negative 1 plus 5, which gives you an answer of 3. So a is 2 and b is, now a is minus 1, sorry, and b is 3. Okay, so I'm just going to put it here. A is minus 1 and b is 3. Is that correct? Right. At this point, you can pause the video if you need to capture or write down whatever you need to. Also, the question paper and memo can be found in the description box below. Okay. So coming back to this here in question 3.2.2, we are told that the equation of the line perpendicular to PQ but passing through P. Determine the equation of the line which is perpendicular to PQ. So if this is PQ, P, what's the coordinates of P? Remember, P is AN minus 3, AN B minus 3. So what is A? Negative 1 And B is 3 minus 3 is 0. Then Q. Let's look at Q. A is negative 1. So negative 2 times negative 1 is 2. And if I put B in there, 3 plus 1 is. Is that not right? Determine the equation of the line perpendicular to PQ, but passing through P. So this is the equation I need to follow to determine. That's all. It's perpendicular, so what do we know? The product of the two gradients is negative 1. So I need to get the gradient of PQ first. Lots of. So PQ is going to be 4 minus 0 over 2 minus 1 is 1. So it's 4 over 3. So this gradient is 4 over 3. So what is the gradient of a perpendicular line? We know that 4 over 3 times the second gradient or the perpendicular gradient is negative 1. So it's going to be minus 3 over 4. Okay? So now we got the equation y is equal to minus 3 over 4x plus c. Now we substitute p, which is negative 1 and 0. Remembering that's an x and a y. So 0 is equal to negative 3 over 4 times negative 1 plus c. Negative 3 over 4 times negative 1 is 3 over 4. Take it over the equal sign becomes negative 3 over 4 again. So y is equal to negative 3 over 4x minus 3 over 4. Is that correct? Right. Any questions here? It was a long question, huh? Go. How many marks? 30 marks? Yeah, 30 marks. I see these. Alright, let's look at question 4. This question must be answered out using a calculator. Where applicable, the answer must be left in third form. Let's go to the first one. The diagram P is the point 2 and negative. Yeah? What's wrong? P is a point 2 and negative 2 root 3, and PR is perpendicular to the x-axis. The reflex XOP is equal to h, the angle, that's the reflex angle there. Calculate the following, the length of OP. People, this is an x and a y. So you got negative 2 root 3 there, x is 2. OP is Pythagoras, the hypotenuse. So OP squared is equal to 2 squared plus negative 2 root 3 squared. That's going to give you 4 plus 4 root 3 squared, which is 3, 12, 16. So OP works out to be 4. Remember, the length will never be negative. Okay. Let's look at the next question. Now they're asking you to work out cos of negative a. So cos of negative a, so what I do is I add 360, so it's 360 minus a. Remember, if I add or subtract 360 from an angle, I don't change the value of it. Alright, so 360 minus the fourth quadrant. Cos is positive, so it's cos of a. So cos is adjacent of hypotenuse. So it's 2 over 4, which is half. So this reminds me now of a special angle triangle. Okay. So with that being a special angle triangle, and the triangle's lying like this, if this is 1, 2, as cos is adjacent of hypotenuse, then this has to be 60. Because if this is root 3, and 30 is here, sine of 30 is 1 over 2. So this angle is 60 here. Just in case we need it. Okay. The next question is to work out tan of 180 minus 8. So tan of 180 minus 8. So we ask ourselves, okay? All stations to Claremont. Here's 180. 180 minus 8 takes you to quadrant 2. Is tan positive or negative? Negative tan of A. Now we go back to this triangle here. This is A, no? That's your reference. So tan is opposite over adjacent. So it's negative 2 root 3 over 2. Gives you positive. No, this must be in two negatives. So this minus is that negative there. Tan is negative 2 root 3 over 2. Which is, that cancels. The negative times negative is positive. Answer is root 3. Correct? And then they want to know sine of A. So it's negative 1 root 3. Sine of A. Sine is opposite. Negative 2 root 3 over hypotenuse minus 1. So of course the root 3 cancels the root 3. Negative times negative is positive. 2 going to 1, 2 going to 4 twice. So it's 1 over 2 minus 1, which is negative of 3. Is that correct? Right. Next question. So in 4.2 they ask you to simplify. So in which quadrant is 150 degrees? The second quadrant. Is all stations to Claremont. How do we get into the third quadrant? 180 minus. So it's 180 minus 30 times 10, 2 to 5. In the third quadrant, 10 is positive. Third quadrant says 180 plus 45. You don't have to write it, you can go straight as well. No? Sine of negative 60. There's going to be some sine 360 minus 60. Or if you know that sine is negative in that quadrant, you can just write it negative sine 60. And then that is 480. I subtract 360 from 480. What do I get? 60. 360 minus 480. 120. It will be 10. 120. Now 120 is the same as 180 minus 60. Okay. So let's simplify. 180 minus 30 takes in the second quadrant cause is negative. Cos of 30, 10 of 180 plus. Second, third quadrant, 10 is positive. Over sine 360 minus, sine is negative. One 180 minus 60, 10 is negative. Okay. So three negatives will give you an ultimate answer of negative there. So it's a special angle, so I go 30, 1, 2 root 3, 60 there. The 45 degrees is 1, 1 root 2. So cos of 30 is adjacent, which is root 3 over 2. Tan of 45 is 1 over 1. Sine of 60 is opposite over hypotenuse, so it's root 3 over 2. Tan of 60, opposite of adjacent, is root 3 over 1. Okay. So what happens? As we know, the answer is negative. So on top you will have the root 3 over 2 must be divided by root 3 times root 3 is 3 over 2, which is negative. Root 3 over 2 multiplied by 2 over 3. So it's negative, that cancels. Root 3 over 3. Okay. Is that correct? No. Okay, where did I go wrong? Check the memo. Check where did I go wrong. Huh? Do I have the answer wrong? No, right. Okay, let's check. So it's going to be cos of 150 times 10 of 2 to 5 over sine negative 60 times 10 480. Right, this is right. What's the answer I got in the memo? Negative 1 over root 3. The same thing, man. Remember that the denominator is rationalized. That's why. Huh? The denominator is rationalized. So in the exam, both will be accepted. Okay. But anyway, 4.3.1 given that day. This is prove the identity. I start off by drawing a cost diagram. Alright, 180 plus is in which quadrant? So this is of course the left hand side. Okay. Sorry? Third. Cos is negative. Negative cos theta. 360 minus takes you to the fourth quadrant. Tan is negative. 90 minus is in which quadrant? First quadrant. Sign positive negative. But changes to cos. It's over. The minus 180. We add 180 or 360 to that. 180. So it's 180 minus theta is in which quadrant? Second quadrant. Sign positive and negative? Positive. Okay, so it's sine theta plus. Okay. 90 plus, which quadrant is that in? Third quadrant. Is cos positive or negative? Negative. But because of the square, it remains positive. But changes to sign. Okay. So what can happen here now? You can change. Okay, negative times negative is positive. So the ultimate answer, that fraction is positive. What can happen to sine to 10? Sine over cos, no? So it's going to be become cos theta times sine theta over cos theta times cos square theta over 1 all over sine theta plus sine square theta. Now what? Cancel the causes, not so. So we have sine theta, cos square theta over sine theta. Now what? Sines cancel, not so. So what do I have? Cos square theta plus sine square theta. Which is equal to? Which is equal to the right hand side. Many of you are saying, this is a giveaway one, né? This is a giveaway for 7 marks. 7. No? Some of you don't even get 7. The whole exam. Here's at least 7 marks you can get. Okay? Right, let's look at the next question. The question says for which values of x, which values of theta is the above identity undefined? So firstly, I see a tan, not so. So that in simple 4 terms is negative tan theta, not so. But draw that graph, the negative tan graph. That's what the tan graph is going to look like. Not so. So firstly, the value for which this will be undefined is where theta is equal to 90 plus k times 180. As you can see, this is going to happen every 180 degrees. Okay. Then, where else would this be undefined? Is when the denominator is equal to 0. The denominator in simpler terms would be, it was 180 minus the sine of theta here it was, no? So when I draw the sine of x graph, where sine of x 0? At 0, 180, 360. Not so. So that's going to happen every 180 degrees, as you can see here. So I say, or theta is equal to 0 plus k times 180. Okay. Where k is an element of integers. Okay. Any confusion here? No, you guys are confused. Yes. What? You worried about the timetable? Are you gonna pause your maths exam? Huh? Take it. If that's more important than listening, then take it. Right, let's go on. Right, you made a good choice. Well, general solution. Since you want to fix the timetable, talk to me through this one. Huh? Don't be like that. Try. Oh, is this the only thing you don't understand? Okay. I'll ask you later. Alright, so firstly we're going to change cos to sine. How do we change sine to cos or cos to sine? By using its correlation. So it's sine 90 minus the angle in question. Not so? So I can drop this. So my reference, x minus 20 is equal to 90 minus 30 is going to give you 60 minus x. Okay. So the question comes to mind, in which quadrant is sine positive? Which quadrant is sine positive? 1 and 2. So let's go with quadrant 1. What do I write for quadrant 1? X minus 20 is equal to 60 minus x plus k times 360. People, I don't solve for x at this point. Okay? So x is one side, so it's going to be 2x is equal to 80 plus k times 360 divided by 2. So x is equal to 40 plus k times 1. Let's check in the other quadrant. Quadrant 2. How do you move into quadrant 2? So 180 minus 60 minus x plus k times 360. So it becomes x minus 20 equals 180 minus 60 plus x plus k times 360. You see that x is cancelled here. So 0 is equal to 120, 140. But what do you notice? Can this be the case? No, so no solution on that one. Okay? So what do I say? X is an element of integers. Alright. And then we are told to determine the value for x. Actually, the values or value for x, for which x is an element of negative 360 to 90. So I must now use this general solution here. Can you see that? So now I go, I say, okay, x is an element of, and I start listing. I start putting a 0 there by k. Then I get 40, which is within this given domain. Okay. So if I put k to be 1, it's 220, which is outside the 90. So do I write it down? No. So now if 1 doesn't work, 2 won't work, 3 won't work, and so on. Now you put minus 1 in. So it's 40 minus 180 is negative 140. Now you put minus 2 in, which is negative 360, which is negative 320. I'm going to put minus 3 in, which is definitely below negative 1. You see that, people? And then I stop. Okay. Any confusion there? No. So here we are told if cos of 27 is equal to m, determine the following in terms of cos 27 is m. So, what does cos stand for? The adjacent over hypotenuse. So your adjacent is m, your hypotenuse is 1. So how do I get this third side here? Apply Pythagoras. Not so. So 1 squared is equal to m squared plus your opposite side squared. Again, over the equal sign, so it's 1 minus m squared is equal to your opposite side squared. Square root thereof is 1 minus m squared. You can't take the square root of it because it's a plus or minus between. Okay. And this unknown angle here, of course, you're going to say 180 minus 27 minus 90. Gives us 63. Just in case I got the angle of 63 coming up there as well. Okay. But I haven't answered the question. The question says cos of negative 387. So what do? Is I add 360 to it. You know what do I get? Negative 27. Not so. So it's either I'm going to say 360 minus 27, or I know that is in your fourth quadrant. So it's just going to become cos 27. What is cos of 27? M. So the first answer is M. Let's look at the next one. Huh? Okay, the next question. That's all I need basically. Sine 27. So sine 27. Sine is opposite. So it's the square root of 1 minus m squared over adjacent. So it's 1 minus m squared, the square root. Number 3. The other one to know. The other one to know, tan of 153 divided by sine 207. So it's sine tan 153 over sine 207. So 153 is in the second quadrant. So it's tan 180 minus over sine 180 plus 27. Is that correct? So it's going to be a tan in the second quadrant is negative, so it's negative tan 27 over negative sine 27. That cancels. Now this is sine over cos, not so. So you're going to say sine 27 over cos 27, which must be divided by sine 27. This is the same as multiplying it by 1 over sine 27. That cancels, leaves you 1 over cos 27. Cos 27, of course, is m. It's 1 over. Otherwise, you could have, what you could have done as well is, we could have taken this sine as tan 27, tan is opposite over adjacent. It's going to be the square root of 1 minus m squared over m must be divided by sine 27. It's going to be opposite, which is the square root of 1 minus m squared over 1. Then becomes the square root of 1 minus m squared over m times 1 over square root of 1 minus m squared, which in turn gives us 1 over m. Okay, either or, you'll get the full mark for that sum. Okay, there's many ways of doing things in mathematics. Okay. So basically, we got 6 minutes left. The sum will definitely not take us 6 minutes. Okay. So we'll stop here for today. So in our next lesson, we probably can wrap up. Okay, you guys are saying let's rather carry on. Okay, this is okay. So in the diagram, the graphs of f and g are drawn with f equals a cos of x. So the a value tells us about the amplitude of this graph. Not so. If you look at the amplitude here, it's going to be 3 to the neutral, so it's 3 units, and it's in the right shape, so a is 3 already. We're going to look at the b. The b is dealing with sine. And the sine graph, is there any change on the sine graph? No, so the b value is definitely 1. Okay, there's no period change when I'm shifting on that graph. Okay, so your a value is 3 and your b value is 1. Alright, let's look at the next question. So I'm just gonna write down the equations here. So my equation of course is f of x is equal to 3 cos x and g of x is equal to sine x. Okay. Let's look at the next question. They want to know, determine the value of p. So as you can see here, p is at the point of intersection. Not so. So you can either substitute this x value into the f graph or to the g graph. Okay. 5.2. So f of 71.6 is equal to. So 3 cos 71.6, you give an answer of? Sorry? 0.9. Then we'll stop here. Hopefully in the next lesson we'll be able to wrap this up. People enjoy the rest of your day. Good afternoon, class.